questions on any of these? All right. Let's move on. 1.2 is inductive reasoning. So the objective is to use inductive reasoning to make conjectures, and we are going to learn what all of. Now you will have vocab words on a lot of your. How do you think we fill in this statement? What should we try to do? Come up with what? Two numbers. Very good. So we're going to come up with some examples. So the sum, what does sum mean?
Addition.
We're going to add of any two odd numbers. So we're going to add two odd numbers here. These are both going to be odd numbers. Equals blank. Okay, what did you pick, Edward? 3 and 7? What's that give me? 10. What's another one? Two odd numbers. 11 and 11 and 1 gives me 12. Okay, what's something else? What'd you say? 1. What'd you say? You had one, didn't you? No? Ann, you got one? An odd number? Sean, you got an odd number for me? 1 plus 1? Perfect. Equals 2. What do you notice about all of these answers? They are even, so our answer is even. Put like one of those examples down, like 3 plus 7 equals 10, or 1 plus 1 equals 2, below it. Cool. Think again, what is product? Multiply. Of any two odd numbers. So we're multiplying what? Two what? Okay, give me two odd numbers. 1 and 7? That equals 7. Okay, give me another one. Give me two more odd numbers. 5 and 3 equals 15. Jalen, what'd you say? 3 and 3. Okay, what do you notice about all of these answers? They're all what? Odd. Okay, so write one of those down. 3 times 3 equals 9, or 5 times 3 equals 15. The product of any two odd numbers is odd. And then once again, you can cross out B. We're not going to do that one. I don't think I even wrote that down. I didn't? Okay, thank you. Okay, questions on the conjectures, completing these statements. Now, on your homework, I give you the examples. So what are you going to look for? Starts with a P. A pattern. You're going to look for a pattern. So if they're all odd, they're all even, they're all positive, they're all negative. Cool? All right. We got a vocab word coming? Okay, counter example. It's an example that shows a conjecture is false. So we're proving that the conjecture is wrong. On this, let's look at an example. Okay, we're going to look at them with the numbers first, okay? Show that the conjecture is false by finding a counter example. Okay. The sum of any two numbers is always greater than the larger of two numbers. This is wordy, so let's dissect it a little bit. Okay, the sum. What does sum mean? Adding. And we have two numbers. So we know we're going to have to add two numbers. Okay? Is always greater than the larger of the two numbers. Okay, so give me a number.
5 plus 5.
Hold on, let's start with 5. What could I add to that where my answer is going to be smaller? Because it's saying my answer is always going to be greater than 5. What could I add to that to make it a smaller number?
Negative.
A negative. What do you want to do? Negative, let's do negative 3. Oh, sorry, I'll do 2.
We gotta write this down?
Yep. What's my answer going to be? Positive 3. Yep. So the sum of two numbers, so we have two numbers adding, is always greater than the larger of the two numbers. Okay, so the answer isn't greater than 5. So I just proved that statement wrong. This is probably, I think, the hardest concept in geometry.
So what you saying is I'm like fair.
No. It's just, you are not going to fail. This is harder, so I'm going to work through it with you, okay? Alright, let's do the next one. The product of two numbers, if the product of two numbers is even, then the numbers must be even. Okay, so product, what does product mean? We're multiplying, and we have two numbers, so we're going to do blank times blank equals blank. What is my answer? What are they telling me? The product of two numbers is even, then the numbers must be even. So they're saying my answer is going to be even. But they're telling me that both these numbers must be even here. Okay, we don't want to prove it correct, we want to prove it wrong. So what should one of these numbers be? Should they both be even? One of them needs to be odd. Let's do 3. 3 times what will give me an even number? 3 times 6 will give me an even number. 18. That proves that statement wrong. Okay, let's do another one. What about 5 times 4 equals 20? That's an even number. So they're telling me that neither of these, both these numbers have to be even, so we're trying to prove that wrong. This is odd. Once again, I will help you with these. These are so tricky. Questions? Alright, I'm going to keep rolling. Okay, is this our last one? No? Okay. Find a counterexample. If the sum of two numbers is positive, then the numbers must be positive. Okay, so they're saying if my answer is positive, this is positive, then both my numbers have to be positive. What could I have in this then? A negative, right? Let's do -2 plus what will give me a positive number? -2 plus -2 will give me -4. We want it to be, the answer to be positive. 7. That'll give me a positive what? 5. So it's saying if the sum of these two numbers is positive, then the numbers must be positive. Well, we just proved that wrong because we just had a negative number. Plus a positive gave us a positive.